Hello everyone, my name is Omero and I'm gonna solve the final question for Signals and Systems class today. I have here two transfer functions of LTI systems described by these equations, and I have to define and classify my two system as a low pass, high pass, band pass, or all pass filters. And I must do this by sketching the magnitude of each of those frequency response of the systems. Then I will determine the impulse response of my first system, and to do so I'm gonna need to apply my inverse Fourier transform on my frequency response. To define my system as some kind of filter, I need to sketch my magnitude response of the system first, and I can do this just multiplying my my impulse response, my frequency response actually, by its conjugated and extracting my square root of it. And when I do this for the first system, I get my I find that my magnitude response is 1 for all frequency. Since my magnitude response is 1 for all the frequencies, any input of any frequency that comes in my systems gets out with the same magnitude. So therefore my system is an all pass filter. For my second system, I have my system defined by this expression, and it's 1 for any frequency greater than 40 pi and 0 otherwise for absolute values of my frequencies. When I sketch my magnitude response of the system, I can see that any signal that comes in my system that is greater than, that has a frequency greater than 40 pi, I have a full response of the system, and my system also attenuates any signal that has frequency lower than 40 pi. So only signals that has high frequencies can pass through the system, and therefore my system is high pass filter. To find my impulse response of my first my first system, I need to apply my inverse Fourier transform on my equation, and to do so I must first write my frequency response in a more familiar way. I have my frequency response written here as minus 20 minus j omega plus 40 over 20 plus j omega, and I can split my division writing as two different divisions. I can write this term over here as minus 1. This simplifies to negative 1, and this is just a scaled function of my it turns out to be just my scaled function of my scaled version of my exponential function. My negative 1 has an inverse Laplace transform, inverse Fourier transform that is minus delta of t, and this is just the Fourier transform of my exponential function times u of t scaled by 40. So that's all. It's not very difficult. It just needs time to see what we have to do.